So one look at the screen and you could probably tell what this video is all about. That's right, it's multiplying a fraction times a fraction. Let's get right to it with an example. Here we go, 2/3 times 1/4. And we've seen this multiplication sign before. We think about the phrase groups of when you see the multiplication sign. So if you say 2/3 groups of 1/4, that sounds a little bit weird. So instead in math we simplify it to saying 2/3 of 1/4. And we've seen multiplication problems before, and we've usually had 4 strategies to solve them. And they look like that: repeated addition, the number line, area model, and the multiplication smart cut. Now, the thing about repeated addition is it only works when you're multiplying by a whole number. And in this case, it's a fraction times a fraction. So unfortunately, one of your favorite strategies, repeated addition, isn't going to work. Now, the number line could work. It's a little bit complicated, but for today, we're actually not going to talk about it and instead focus on 2 strategies, the area model and the multiplication smart cut. So let's start with the area model, please. Here we go. 1 box. I know you guys are used to seeing 9, 12, 6 boxes, but in this case, when you're multiplying a fraction by a fraction, it's only going to be 1 box, and that box represents 1 whole. And you're like, yo, why do we only need 1 box? Well, think about it. You're multiplying something that's less than 1 times something else that's less than 1. So you're still going to get an answer of less than 1, which means all you need is 1 whole box to do the area model for a fraction times a fraction. So let's get started. We're actually gonna take 1/4 and we're gonna put it on the top. And I know some of y'all are freaking out, being like, oh, you have to put 1/4 over here and 2/3 up here. It doesn't matter. The commutative property of multiplication states that you can put this fraction anywhere you want on this area model, and you'll still get the same answer. So let's say I was going to put 1/4 up here. How many pieces do I need to cut it into? Call it out, please. That's right, 4. And how many jumps would I need to make if I'm doing 1/4 starting over here? Call it out. 1 jump is right, which means that that little piece right here is 1/4. Don't forget to extend those lines all the way down for all of the lines. So we did our first bracket for 1/4. Now we got to do which fraction? 2/3 is correct. All right, here we go. I'm cutting this vertical line segment and want to show 2/3. How many equal pieces do I need to cut it into? Call it out, please. 3 is right. And how many jumps do I need to make to show 2/3? Call it out. 2 is right. 1, 2. Bracket it up. And that is 2/3 right there. Don't forget to extend your lines. And that's what we have so far. We made our brackets for 2/3 right there. Our bracket for 1/4 right there. And now we need to figure out how much of this whole are we going to shade in. Why don't you whisper it right now? How many of these pieces do you think we're going to be shading in? Go ahead, whisper it. Did you whisper 2? If you got that one, point to the next one. That's right, you're going to be shading in 2. Last question, we're almost done. How much is just one of these pieces worth? Go ahead, call it out. If you said 1/12, you were right. That's 1/12 and that's 1/12 because it's 1 piece out of 12 total boxes in the whole. Which means that when you do 1/4 times 2/3, how many twelfths are you going to get? You're right, 2/12. You know that you can reduce that. What do you have to divide by? Now, I hope you said 2/2, which is the same as 1 whole. Don't you dare say you have to divide by 2 to reduce or to simplify. You have to say divide by 2/2, which is going to give you what is your answer? Call it out, please. 1/6 is right. So 1/4 times 2/3 gives you 2/12, which also equals 1/6. Now, something about this area model and what we just solved that you might have noticed. We just did 2/3 times 1/4 equals 2/12. And you might be thinking to yourself, is it really that easy? Because I noticed something. Go ahead and talk out loud. What do you notice about how to solve this multiplication problem that maybe you don't even need to use the area model to do. Go ahead and tell a neighbor. What pattern do you see? Okay, did you notice this? Did you notice that 2 times 1 makes 2 and 3 times 4 makes 12? And you're thinking, oh, maybe that works just this time. But no, it is a general rule of multiplication. It is a multiplication smart cut. And it looks like this. And you're like, whoa, what's up with these letters down here? Well, all it means is if you have one fraction, a over b, and you multiply it by c over d, all you need to do is multiply the numerators and multiply the denominators. And that will always work when you're multiplying proper fractions. Okay, and that means you don't have to make it speak the same language, and you don't have to do dumb denominators copy. None of that stuff. Multiplying fractions is probably the easiest thing to do if you think about it through the multiplication smart cut. Thank you as always for listening, and call if you need any help. Deuces.